Assalamu alaikum, this is Abu Bakr Ali, and today we are going to discuss the topic motion. Okay. Before moving forward, don't forget to subscribe and like the channel to get the notification of new videos. Okay. So first thing we are going to discuss about speed. Okay, so how we can define speed? Speed is the distance covered by object in a unit time. That is called the speed, right? And speed is measured in its units are meter per second, and speed is scalar quantity. What was scalar quantities? Scalar quantities are the quantities those have only magnitude, right? They don't have any direction. For the velocity, velocity we can define it as it's the speed with direction. Okay, so speed was, if you discuss the speed, it's a scalar. Scalar mean it only have the magnitude, okay? And when you talk about the velocity, velocity will be the speed with the direction. It's mean it will have magnitude, that will be the speed, and it has direction, right? So the magnitude plus direction. So let's suppose if someone says that car was moving with 40 kilometer per hour, so he's telling you the information about the speed. But when you add that 40 kilometer per hour towards east or any direction, so now they are telling you information about the velocity. This thing is only speed, and as a whole this complete thing is velocity. So velocity is a vector quantity, and its units are also meter per second. As it is vector quantity, so it will change with the change in direction. So if something is moving towards the right side and some object is moving towards the left side, they will have different velocities. They can have same speed, but the velocities will be different, right? Because of the vector nature of the velocity. Okay, next thing is the average speed. Average speed can be defined as total distance covered over total time taken. So that will give you the average speed. So average speed basically tell you about the whole journey. What was the speed, average speed during the whole journey, right? It's not going to tell you about the speed at any instant. Let's suppose if you're moving from one city to another city, the car can have different speed at different points when it's moving through the traffic, or when it is leaving from its destination towards its destination. Okay, it can have different speeds, but what the overall speed during the journey, that will be the average speed. Okay, it is also scalar, and its units are also meter per second, right? Okay, next thing we have to discuss is the graphs. There are two types of graph. One is the distance time graph, second is the speed time graph. Okay, so we are going to discuss them side by side. So in distance time graph, you have to keep in mind, in distance time graph, in this graph, the slope will tell you what speed. But when we discuss about speed time graph, slope will give you acceleration. Okay, so this is the basic difference between both of them. So first we are going to discuss about when the object is at rest, how the speed distance time graph will be and how the speed time graph will be. Okay, for the object at rest, so distance will not change, right? So it will be horizontal straight line. It can be anywhere. It can be at this point, it can be drawn at this point on the x-axis, or anywhere it can be drawn, okay, in distance time graph. But for the object at rest in speed time graph, that line should be on the x-axis. This is showing the zero speed object at rest. If you draw it here, that will be wrong because that is not at rest, it is moving with a constant speed. Okay, so this one is correct. The second graph is about moving with a constant speed. Constant speed mean in distance time graph, slope will tell you the speed, right? So it should be a constant slope. One more thing, straight line represents constant slope, right? So what we have to draw a diagonal straight line, that is a constant speed. And for velocity time graph, constant speed or constant velocity mean basically it will have zero acceleration, so it will horizontal straight line. Okay, so horizontal straight line will show you the zero slope. In that case, zero slope is showing the acceleration. Zero acceleration mean constant velocity. Okay, the next graph is accelerating. Accelerating mean the object is speeding up, right? So when speeding up, its velocity will increase. So what we have to keep in mind, curved line represent what? Changing speed. Okay, so what the change is, it's increasing. If the slope is curving towards the y-axis, it's increasing. If it's curving towards the x-axis, it's decreasing. Okay, so it's increasing velocity, it's accelerating, so it will be like this. Okay, and if it is constantly increasing, constantly accelerating, so for this it will be a diagonal straight line. Next is decelerating. Decelerating mean object is slowing down. So the slope will be, again it's a curved, but it will move toward the x-axis. And for this velocity time graph, decelerating mean negative slope, it's the negative acceleration, right? Negative acceleration. Negative acceleration will be shown by negative slope. So negative slope, it will be like this, it's going downward. Okay, decreasing speed you can say as well. Okay, next thing is for the speed time, for the distance time graph, how we can calculate the speed, the magnitude of it, the exact value, how we can calculate. As shown in the graph, let's suppose that is a case that we have. There are different portions of the graph A, B, C, D. They can ask you anywhere to find the speed. Let's suppose they're asking you to find the speed during the first 4 hours, right? So first 4 hour is basically this region, the portion A. So if we see in the first 4 hours, it's having a straight line, right? From this point to this point. So straight line shows a constant speed. So we can choose any 2 points on this region, this red line, right? So if you choose any 2 points on this, you have to apply rise over run relation, right? Gradient formula you have to apply on it. So let's choose any 2 points and then we will try to solve it. So let's choose one point is this, let's suppose, and second point I'm choosing this as the origin. Okay, first we have to figure out its coordinates. This point is 1, so this will be the x1 y1. So they both are 0 0, right? I have to work out for this. This is x2 y2. Okay, if I look at the x-axis, this thing is basically the x2. If I look at the y-axis, this thing is basically the y2, right? So to find its speed will be equals to slope is equals to rise over run, that will be equals to y2 minus y1, x2 minus x1. I just have to put the values, right? Y2 is 30, y1 is 0, x2 is 4 and 0. Okay, so that will be 30 over 4 meter per second. You just have to calculate the final answer. Okay, so by this rule you can find gradient at any point, right? You can find the gradient for the B, for the C, or for the D as well. Okay, so let's move forward to the next. Same as the speed time graph can be used to find the distance covered. As shown in the diagram, let's suppose examiner asks you to find the distance covered in first 10 seconds. Okay, so for the first 10 seconds, if I see here, the 10th second is at this point. So this is the graph in the first 10 second. So you have to find the area under the graph. So this is the area under the graph in the first 10 seconds. So for this, what I have to do, this is making a triangle, right? Its triangle, its base is, it's starting from this point, ending at this point, its base is 10. And the triangle's height is from this point to this point, that is also 10. So for area of triangle is 1 over 2 base into height, that will be 1 over 2, 10 into 10, that will be 50 meters. Okay, so that will give us the distance covered, right? Area is basically in meters square usually, but this area is equals to distance, so we will take its units distance, right? Meters. Okay, they can ask you the total cover distance as well. So if they ask you to find the total cover distance, you have to find this complete area that is under the graph. So the complete area under the graph is, it's starting from this whole area that you have to find. Okay, this complete area. So what we can do, we can divide this area into different shapes, into rectangles and triangles, right? So if we see, this is making a triangle, this is shape 1, this is shape 2, this is a small triangle, shape 3, this is complete rectangle, that is 4, this is a complete triangle, that is 5. So you have to find individually the area of all the shapes, and then at the end you have to add them all. That will give you total distance covered of the object. Okay, okay, next we have to define acceleration. How we can define it? Acceleration is basically, we can say, rate of change of velocity, or we can say a is equals to delta v over delta t, or it can be written as v minus u divided by t. V is the final velocity, u is the initial velocity of the object, right? Its units are meter per second square, and it is also a vector quantity. It's mean it depends on the direction. If the direction of the object will change, the acceleration will change, right? Okay, so how we can calculate the acceleration of the object from the graph? Okay, it's the same as we have calculated the speed from the distance time graph. Same, we can calculate the acceleration from the speed time graph, right? So let's suppose they asked you to find the acceleration for the first 10 seconds. So if you see on the graph, the first 10 seconds, the graph is from this point to this point, this is a straight line. So what we have to do, we have to choose any 2 points on the straight line. Let's suppose I'm choosing one point this, and the second point is this. So this is x1, y1, these coordinates are x2, y2. x2 is basically this point, y2 is basically this point. So acceleration in that case is equals to slope, that is equals to y2 minus y1 divided by x2 minus x1. y2 is 10 and y1 is 0, x2 is 10 and x1 is 0, that was 10 by 10, that will give you 1 meter per second square. Okay, so same as you can find the acceleration between the 30 to 40 as well. It depends on the question what they ask you, right? So if they ask you to find the acceleration between the time 30 to 40, you can choose 2 points on the graph. Let's suppose one point is this, second point is this. You just have to sort out their coordinates. This one will be then x1, this one will be the y1, and this will be the x2, y2. Okay, so the value of x1 will be 30 in that case, particular case. Okay, and let me erase the previous one so we will not be confused. Okay, for this case the x1 will be the 30 and y1 will be the 15, and this is the second point. If we are taking this, will be the x2 and y2 will be 0, right? So you just have to apply the formula and there will be new values for this. Y2 is 0 minus 15 divided by y2 is x2 is 40 minus 30, so that will be minus 15 over 10, that will be minus 1.5 meter per second. So you are getting the negative answer. Why? Because it's the deceleration, it's a negative slope. Okay, so that is how we can find the acceleration from the slope, from the gradient, right? Okay, that's it.